Hello everybody and welcome back. Root Beer here with the very last question, question 25 on the 2005 Grade 8 Gauss paper. A purse contains a collection of quarters, dimes, nickels, and pennies. The average value of the coins in the purse is 17 cents. If a penny is removed from the purse, the average value of the coins becomes 18 cents. How many nickels are in the purse? Interesting. So the average value of the coins in the purse is 17 cents. If a single penny is removed from the purse, the average value of the coins becomes 18 cents. So, as just a fun little numerical or monetary, that's the word I want, monetary refresher for anyone who might be watching this outside of North America, a penny is worth 1 cent. A nickel is worth 5 cents. A dime is worth 10 cents. And a quarter is worth 25 cents. I'm going to let P be the number of pennies, N the number of nickels, D the number of dimes, and Q the number of quarters. Why am I doing that? Because I need to know how much of each if I'm going to get an expression for the total and for how many coins there are. And that's how we calculate average. You need to have the sum of all the numbers divided by how many numbers. So these numbers will be, what do we want? We want how many nickels are in the purse, so that's not going to change a whole lot. So these will be the number of each coin at the start. Okay, because I know we remove a penny. So we know that 17 cents is the average of all these. Well, how many pennies do we have? We have P pennies, and we get 1 cent per penny, 5 cents per nickel, 10 cents per dime, and 25 cents per quarter, and we average that out with P plus N plus D plus Q, the total number of all of these. And then we remove 1 penny. And suddenly our average becomes 18 cents. How many pennies do we have? We have 1 less penny. Still have the same number of nickels. Still have the same number of dimes. We still have the same number of quarters. And how many coins are we averaging? Well, 1 less penny, but same number of nickels, same number of dimes, same number of quarters. Okay. So these expressions here are very similar to one another. And I'm tempted to try and get an equation linking the two. So what I'm going to do is I'm going to take both these equations. I'm going to call them maybe equation 1 and equation 2. And I'm going to get rid of the fraction part. So I'm going to multiply equation 1 by P plus N plus D plus Q. And I'm going to multiply equation 2 by P minus 1 plus N plus D plus Q. So we're going to get 17 times P plus N plus D plus Q. And that's going to be equal to 1P plus 5N. I'm dropping the cent sign just because it's extra writing that's only going to serve to clutter things up. And what else do we have? 18. We've got P plus N plus D plus Q minus 1 because we did take out 1 penny. So that's P minus 1 plus 5N plus 10D plus 25Q. So we have certain parts of these equations that are very similar. They're almost begging to be canceled out in some way, and I think we'll get there. I want to do a little bit of expanding and rearranging first. So we might call this, say, 1 prime, this one 2 prime. So I'm going to expand. I'm going to say 17P plus 17N plus 17D plus 17Q. And that's P plus 5N plus 10D plus 25Q. And what do we have? We have 18P plus 18N plus 18D plus 18q minus 18 is p minus 1 plus 5n plus 10d plus 25q. 1 double prime, 2 double prime. Now, look how similar these are. Over here we've got the same numbers, or same values, p and d and q. They're just off by 1 coefficient. So what I'm going to do is I'm going to subtract equation 1, or 1 double prime, from equation 2 double prime. And it might be easier if you rearranged these and put the 18p and 18n and so forth on top. And if you want to, by all means do that. But I'm going to subtract them in my head. I get 1p plus 1n plus 1d plus 1q, still minus 18. And now we have p minus p, so nothing. We still have a minus 1 here. And we get 5n minus 5n. 10d minus 10d, 25q minus 25q. We're just left with a minus 1 over here. So we get p plus n plus d plus q. We can move the 18 over to the other side, and we'll get 17. Now, how does this help us? How does this help us? Well, there's a couple things we can maybe make note of. All right, we have p plus n plus... This is the total number of coins we started with. That's fantastic. It's not quite what we wanted, though. We want the total, how many nickels were in the purse. Okay. But knowing that we've got this 17, we could maybe plug that into equation 1. And then we know p and 5n and d and q. Those are fantastic things to know. What else could we maybe do with this? Well, we know when we remove 1 coin, we get 1 less coin, so we'll have 16 here. So that's p plus n plus d plus q minus 1. So we can plug that in here. So, is there any other piece of information we might want to use? Well, I think we just want to say take this and plug into 1 prime and 2 prime. I can't remember how to do the ampersand sign now. Don't I look like a fool? I'll just write and. Sort of like an 8. Anyway, so let's plug this back in. So we've got 17 times 17, that's 289. And that's p plus 5n plus 10d plus 25q. And 18 times 16, that's 288. And that is p minus 1 plus 5n plus 10d plus 25q. And we can move the 1 over to the other side and get 289, which is the first equation again. So we haven't learned a whole lot of anything new by plugging that into 2 prime that we didn't learn by plugging it into 1 prime. Okay. So we got this equation right here. And really the only other thing we know is the sum of each of these. Oh, not 25, just a q there. This is all the information we really have so far. But if I line it up this way, you know, this is 1 prime and maybe this is equation 3 or something like that, I can subtract these two. So, 289 minus 17, we'll get to 272. The p's will drop out, and we'll be left with 4n, 9d, and 24q. Now, this is at least a little helpful, because now we don't have, now the lowest thing that we're working with is these nickels. Okay. But something seems to have gone amiss, because I shouldn't have a 2 here. Because nickel, oh no, sorry, this is number of nickels and so forth. Yeah, no, that's fine. For a second there, I thought we should need to have nickels multiple of 5, dimes a multiple of 5, and quarters a multiple of 5. So how would we get a remainder of 2 there? No. So this is perfectly fine. Does this give us any additional information? I feel like we're missing something. Purse contains quarters, dimes, nickels, and pennies. Average value of the coins in the purse is 17 cents. If a penny is removed, the average of the coins becomes 18 cents. How many nickels are in the purse? Well, we've got ourselves down to nickels. What else can we do with this? It's almost as though there's got to be only one way to solve this equation here. And I suppose nickels and dimes and quarters. So since we remove a penny, there's got to be at least one penny. So if we just had nickels, dimes, and quarters together, that would be at most 16, because there's got to be one of those 17 coins has to at least be a penny. There might be more, there might be less, who knows? Well, there's not less, but there might be more than one penny. But there's at least one penny. So knowing that nickels plus dimes plus quarters has to be no greater than 16, I'm betting there's only one solution here for N, D, and Q. So let's see if we can work it out. So maybe N, D, and Q. And then 4N plus 9D plus 24Q. Alright, now before I start filling in this chart, I actually just noticed something. This is N plus 3N plus 9D plus 24Q. So this is N plus 3 times something. And 272 is it's 3 times 90 plus 2. Does this mean N is 2? No. But when it comes to multiples of 3, there's the remainder of 2 left over, and over here N has to have a remainder of 2. So N must leave a remainder of 2 when we divide by 3. Okay, so this might help us out. Now, 272 is quite big. I imagine we're going to be using a bunch of these quarters just because 24 times the number of quarters will certainly beef this number up. And yeah, so how many quarters could we have at most? 272 divided by 24 is 11.3 repeating. So I might be able to say something like, we'll put 11 here, and then we'd get 24 times 11 is 264. That would leave 8 remaining for the remainder of the coins. So that'd be 0 dimes and 2 nickels. Well, hey, that works. Is that the only thing that works? Because if it isn't, we've got more to rule out. So what if we had 10 quarters? Well, we'd have 240 here. And that would leave 32 left for the... so 272 minus 240 is 32. We would need to... So we could have 8 nickels, but then that's 18 coins. That's too much. We could have 3 nickels, and maybe a certain number. No, so how can I get 4N plus 9D equal to 32? That's what we've got left to do. So we could have 1 dime, which would be 9, or we could have 2 dimes, which would be 18, or 3 dimes, which would be 27. Neither of these odd numbers work because you'd be adding to an even number with 4n. So you'd have to have 18 here and 14. Well, 14 is not going to work, so nothing there. How about 9 for the number of quarters? We'd have 24 times 9, which I can't remember what that is off the top of my head. So we go to the calculator. 216. So 216, what's left over? 56 needs to be made now. So 56, if that were done with, how many dimes could we have at most? We'd have at most, not 9 dimes, we'd have at most 6 dimes. And that would leave 2. So that wouldn't, 2 for the 4n would have to be 2, and that wouldn't work. What if we had 5 dimes? Well, that would be odd, and 4n wouldn't work there, so we'd have to have 4 dimes. And so that would be 36, so that would leave us 20 for 4n nickels, and so that would be 5 nickels, but then 5 plus 4 plus 9, that's too many. How about 8 quarters? Then you would have 24 times 8. So that'd be 192, and that would leave us with 70 for the sum of 4n plus 9d. So at best, the number of dimes you could have would be 7 dimes, and that would leave us with 63, so that's not going to work. How about 6? Well, that'd be 54. And so we'd need 16, so we'd have 4 nickels. Again, that's too much, and it's going to keep being too much. We're going to start running into a situation where you have too few quarters making up the bulk of this, and the condition of n plus the number of coins being at most 16 starts to play a bigger and bigger role. You need to have a bunch of quarters, otherwise you're going to have a massive number of dimes and nickels in order to make 272, and it just won't work. So really, we do have just the one solution. 2 nickels, no dimes, 11 quarters. So there are 2 nickels in the purse. Now, hopefully 2 is one of the answers, otherwise we've done something terribly wrong. 2 is indeed one of the answers, and notice that my comment about divisibility by 3, leaving a remainder of 2, ruled it down to A and B. So had I been paying attention, had I gone back and said, okay, does this new information rule anything out, we could have ruled out C, D, and E just by noting that n has to leave, the number of nickels has to leave a remainder of 2 when we divide by 3. And so maybe I couldn't fill in that chart, maybe I couldn't actually rule things out, but I did have that information. I could have said it's either A or B, and if it's down to A or B, that's when you want to take a guess. We want to try and do the best for our points. We'll run out of time, that's when we guess. Obviously, if you still have time, fill in the chart like I tried to do and work out and say, well, no, eventually we're just going to have too many quarters to make this work. It's got to be 2 nickels, 0 dimes, and 11 quarters. But if you had just worked out that divisibility by 3, leaving a remainder of 2 thing, and your proctor says 1 minute, you say A or B, it doesn't matter, flip a coin, and 50% of the time you'll be right. And so that might net you 8 marks. Because no one's checking your work, no one's saying, do they actually understand this question? You can go through and guess everything, but statistically you're not going to get a good mark. But if you can narrow it down to best of 3, best of 2 is even better, then yeah, it's worth taking a guess. If you don't know something, as always, leave it blank. You leave a question blank, you get 2 marks for being able to say, I don't know. And that's what I like about these multiple choice contests from Waterloo. They value being able to say, I don't know, I don't understand, and that's an important skill to be able to do, even if it's in private on a math contest. So if you can't rule it down to 3 or 2, don't take a guess. Leave that blank, get the guaranteed 2 marks. But if we could have ruled it down to A and B, if I'd stopped and said that, and gone back and checked my answers, then I would have said, yeah, this is the time we take a guess, assuming we ran out of time. Anyway, I'm going to stop rambling. That's it for the 2005 Grade 8 Gauss. I think the next thing I'm going to do is the Pascal or the Fryer, one of the two. So the grade 9 contests are up next. So if you're looking for a bit of a challenge, stay tuned for the Pascal. And if you want to look at any of my other Gausses, what's online is online, and I'll always be adding more in the future. So thanks for watching, and have yourselves a wonderful day.